Many of the types of molecules that we eat include functional groups. So one example of that are fats and oils. They contain carboxylic acid groups. In this particular image, all three of these representations show the same fatty acid. So we've got a carboxylic acid group on the far left side. We have our carbonyl attached to an oxygen, and then a long fatty acid chain, a long carbon containing chain. Now technically the molecules drawn show fatty acids. In order to make fats and oils, it is something called a triglyceride. So there is a glycerol molecule that holds three of these chains together. So we wouldn't have the hydrogen at the end, but we would have this backbone that holds the three fatty acids together, and that's why they're called triglycerides. You may have heard that term before, you may not have. And they contain three fatty acids. We are going to look more specifically at the fatty acids, and the reason they're called fatty acids is because of that carboxylic acid group. That long carbon chain makes it hard to dissolve in water, and so it's very nonpolar, and that long carbon chain is what makes it the greasy. Okay. So triglycerides contain three fatty acids. We're going to look more specifically at fatty acids. Okay. So when we look at them, there's different ways we can classify them. So we can classify them as saturated, and we think of saturated as in it cannot contain any more hydrogen. So it contains all carbon-carbon single bonds. There's no way that we can add additional hydrogen into the molecule. So these tend to be solids at room temperature. So we typically refer to these as fats. They come from animal sources, most frequently, like butter, from the milk of cows, or lard, which comes from the fat in the or near the muscle of animals. And so those are what we typically refer to as fats. So they're saturated, they can't contain any more hydrogen, all single bonds. We also have unsaturated fats, and unsaturated fats are ones that contain one or more carbon-carbon double bonds. And these tend to be liquids at room temperature, and we refer to these as oils. So these are things like olive oil or vegetable oil, and they tend to come from plant sources. Now, coconut oil is a little bit different from that, but just in general, fats tend to come from animals, oils tend to come from vegetables or plant sources. Okay, so monounsaturated means that there is only one carbon-carbon double bond. We can also have something called a polyunsaturated. Any ideas what that may be? That means more than one carbon-carbon double bond. So for polyunsaturated, more than one carbon-carbon. Monounsaturated means only one carbon-carbon double bond. We can have trans-unsaturated fats. So trans, just like we learned in chapter 8, means that it has a trans double bond. So those are actually synthetic. It happens when we try to, if you've ever heard of hydrogenated oil, so we try to manipulate the properties of different fats. And one way we can do that is by adding hydrogen in. So we can take some of these oils, if you've ever used margarine. Okay, margarine, we take these vegetable oils and we hydrogenate them, we add hydrogen in, and when we do that, it results in trans-unsaturated fats. So they've been manipulated to end up with a trans double bond, and they do come from a synthetic source. So trans fats, those are the ones that are not as healthy for us. Okay, so those are synthetic. Monounsaturated, okay, that means, oops, I'm sorry, I've already talked about monounsaturated. We can have cis-unsaturated, so cis means that it contains a cis double bond. Okay, cis-unsaturated, those do come from natural sources. Okay. So let's look at our different fatty acids across the bottom and let's characterize these. Let's decide. So pause the video, see if you can characterize the fatty acids, and then we'll talk about them. So let's start with the one furthest to the left. So we do have a double bond, so that tells us that, and there's only one double bond. We don't count the carbonyl group. So this would be a monounsaturated. Okay, because it's monounsaturated and we have the carbons on the same side of the double bond, that makes this cis, which means it comes from a natural source. Okay. If we look at the second one, okay, now we do again have one double bond that's not the carbonyl. So this is again going to be monounsaturated. Okay. Now if we look, our carbons are on opposite sides of that double bond. And so this is going to be trans. And it is going to be a synthetic fatty acid. And our last one, if we look at this, there are no double bonds besides that carbonyl, so this is going to be a saturated fat. Okay. And so this one would be a solid at room temperature, which means that this has the highest boiling point. How would the other two rank? Think about how the other two boiling points would go. Well, our trans, as we said, we can hydrogenate it to manipulate the properties. So because it's trans, it's going to pack together. Those chains are going to pack together. There's going to be more of our intermolecular forces present. And so this would be the second highest. And our cis is going to have a harder time packing together, so this would be the lowest boiling point. So we're talking about boiling points here. And when we're ranking them, we do have to have the same length chain in order to decide what's the highest and the lowest boiling points for our fats.